Assalamu alaikum warahmatullahi wabarakatuh. In this video, we'll talk about the chemical equilibrium, what we mean about chemical equilibrium, what is the meaning of equilibrium in chemical reactions. Okay, so first, before we start, we should know that we have two types of chemical reactions. The first one, which is complete one, and one was not complete. What is the meaning of this? Complete reactions is mean if you have a reactant and this reactant will convert to a product. So by the end of the reaction, you have only products and no reactant will remain in the system. Or if you have two reactants, A plus C will form B. So by the end of the reaction, at least you will have consumed all the reactants, or at least one of them, which is the limiting, and you will have product in the reaction. So for this one, the mission here for the reaction is to convert all the reactants to product and produce only products. So for other reactions here, if we have A, this will be converted to a B through a chemical reaction. So in the beginning, A will convert it to B through a chemical reaction. But after a time, the concentration of B will start to increase. When this concentration increases to a specific value, B will start participating in the chemical reaction. We will start to do a chemical reaction. What is the chemical reaction that B can do? He will convert it to A. So in this case, we have two chemical reactions here. We have the one who converted reactants to products, and the other one will convert products to reactant. What we can call these two? The first one will be called a forward reaction, and the second will be called a reverse reaction. So we have forward and reverse. So forward reaction when converting reactants to products, and the reverse when converting products to reactant. How this process start? So if we have reactants and we have products, we will start only by reactant. So we have a higher concentration of reactants, so we will start the forward reaction. And we know that there is a relation between the rate of any chemical reaction with the concentration of the reactant. So if you have higher reactant, higher concentration, so you have a higher rate. That's why the forward will start always with a higher rate. So the rate of the forward will start with a higher one. But at a point, as we said, B will start to participate when it has a specific amount, specific concentration, so we will start with the reverse one. But because the concentration of B is still small, so the reverse reaction will start as a small rate. After a while, we will consume more A, so the concentration of A will decrease, so the forward reaction again will decrease, the rate of the forward will decrease, and will forming more B, so that's why the rate of the reverse will increase. And this process will continue decreasing the forward, increasing the reverse until both will have the same rate. At this point, when we reach an equal rate for both reverse and forward, we will have equilibrium. So, and this one will be called a dynamic equilibrium. Why we can call it a dynamic equilibrium? Because we have a motion here. It's not equilibrium that we don't have nothing happen now, but we have two reactions, two processes happen inside the beaker. Let's see how to determine if for a system, if we have an equilibrium or not. We can determine if the system have an equilibrium or not from two things. The first, by seeing the number of the atoms or the concentration of the atom or product or compounds, substance, product, and reactant. And another thing, if we have a graph. Let's start with the first thing here. We have a drawing for a system, and this system is the reaction between A and B to form AB. Okay, so this is the first thing. We have A, which is the green one, and we have B, which is the blue one. This is before reaction starts. So we didn't start the reaction yet. How do we know? Because the product, we don't have any products here. If we check, there is no AB, only A separated from B, so we don't have any reactive products. After a while, after a time here, we will see that AB started to produce. We have AB, this is a product here, but we still have reactants, both of them. Okay, so we have AB. Let's count how many AB do we have. We have 3. More time, so we form more products, so we'll see that we have more of AB. So we have 5 AB, but again, we still have reactants. More time, we still have products. Oh, how many? Now it's the same, it's 5 AB, but we still have reactants. So why the reactants are not consumed, why the reactant are not converted to products. This is why, because they have an equilibrium. So at the beginning, we only form it. We have the forward reaction, reactants will form or give the product. But when this one will start, we have the reverse one started. The reverse one started, but at low rate. So we have still forming more product, okay, but we still have reactant, mean we have the reverse one. After a while here, we can see that the forward is and the reverse, both of them will be equal or having an equal rate. Why? Because the concentration of AB is the same. It means when you are forming or producing one of A, you will use this one to produce AB. So you're producing one AB, you will use this one to, you consume one AB to produce A and B. You will producing two AB, you will consume the same two to produce AB. So the amount of AB will produce will be the same amount to be consumed to form the reactants. So that's why we have equal rate. So we can see that this reaction, it reaches the equilibrium because we have an equal rate for the concentration, and this equal rate can be determined by the equal concentration or the constant equal concentration of products and the reactant. Okay, another thing, we will go for the reaction, which is synthesis of ammonia. Let's draw the graph for this one. We have two graphs here. Let's draw the first one, which is time versus the concentration for all reactants and products. For the first, we have two reactants. Let's see, this is hydrogen, and this is nitrogen, and subproduct NH3. Okay, so at the beginning, we have higher concentration of A, high concentration of nitrogen, and zero of NH3 because we didn't start the reaction, we have no products. After a while, we will consume NH2 and we will consume nitrogen to produce products. That's why the product will start to increase. At a specific time, as we see here, we will have, after this time, we will have a constant concentration of hydrogen, nitrogen, and ammonia. This will give us an indicator that we reached the equilibrium. We have a chemical equilibrium here because the concentration will be constant only if you are consumed the same amount you are producing. That's why we have a constant concentration of all reactants and the product, and they shouldn't be equal. They are not equal, but they are constant. Another graph that we can draw to show the relation or so that we reached equilibrium, we can reach again, this is time and this is the rate. Okay, so we said that at the beginning, we have the rate of the forward was high and the rate of the reverse is zero because we don't have a reverse reaction yet. The rate of the forward will start high, but it will decrease by time because the concentration of the reactant will decrease, and the rate of the reverse will start with a slow or lower value and it will increase. Why it will increase? Because the concentration of the product will increase until both will reach the same value, the same rate. So this is the forward one and this is the reverse one. So the rate of the forward will start by a higher value and decrease by time, and the rate of the reverse will start with a lower value and increase by time until both will reach the same value. Okay, so from this, what we can say about the equilibrium properties. First, we have a constant concentration of both reactants and product, but they are not equal. They are constant, but they are not equal. We have something called dynamic equilibrium. What is the meaning of dynamics? So we have motion, we have something happening inside the beaker. What is happening? We have two rates. We have the forward and the reverse, and both rates are equal. So the reverse rate equal to the forward rate. And if we are seeing or taking a scene for the atoms, we can't change or we can see any change happening here. So because there are equilibriums, the amount that you are forming is the same amount that you are decomposing or using for the reverse one. Okay, how to keep the equilibrium? So we have conditions. If we take these conditions in consideration, we can keep the equilibrium state or the equilibrium thing as it is. First, the system should be closed. What is the meaning of closed system? So this is the system of the reaction, should be closed. It means you can't put or remove a substance. So means no change for matter. So you can't remove substance or add a substance, so the system will be closed, so you will keep the equilibrium. The second, you need to keep the constant temperature as constant because temperature can change the equilibrium, especially for the reaction which should be endo or endothermic. We will take one example, which is heating H2O. So I have an amount of H2O here. I will start heating this one, but we are in a closed system. This is a closed system here. So all the matter of H2O, whatever it's a liquid or a vapor, will stay inside the system. When we're heating, so we will start the forward reaction. The forward reaction, it will be starting converting H2 molecules to vapor. And by time, this amount will increase because we're reducing more of the vapor. When this amount of vapor increases, we will start the reverse reaction. And the reverse reaction, so this is the vaporization one, we're starting a higher rate, and the condensation will starting at slow rate. And by time, the vaporization will decrease and the condensation will increase until both will reach the same rate. At this time, the amount of the vapor will stay the same and the amount of the liquid will stay the same. We have a constant concentration for the vapor and for the liquid one. Why? Because what you are converting to vapor, it will be the same amount that you're converting to a liquid.